morning, ladies and gentlemen. Welcome to another edition of me walking you through some practice problems. So, today we're going to be on page 113 in your Module 4 book. You need to make sure you have that. Make sure you have something to write with. And grab a calculator. You're going to need it. So, we're going to start on page 113. This is your Lesson 11 exit ticket. And so, as we make our way through this exit ticket, there's just 3 questions. There's a table to fill out. We'll make our way through. Not going to be too difficult. And we're going to be using a lot of the same things that we've been using over the past couple of examples and exercises. We're going to be given a rate. We're going to put that rate together, put that rate into an equation, and then use that equation to fill out the rest of a table. This is going to be the same thing you're going to be asked to do for your online assignment. So you're going to have to do essentially that same for your 3 questions that are posted. You will give the rate and then essentially answer the question that they ask you, however many, whatever it is, and how many hours of time or minutes of time, whatever. You know the deal. Okay. So starting on page 113, Vicky reads at a constant rate. She reads 5 pages in 9 minutes. We want to know how many pages P Vicky can read after T minutes. So for part A, we have to write a linear equation in 2 variables that represents the number of pages that Vicky reads in any given time interval. So what this means is that we have to create an equation with the y equals kx kind of format that we used last year. Okay. This year, though, I do want to make kind of a reference and make a change, something we haven't done yet, a change that we have not yet made that I want to start making right now. I want this, normally we looked at y over x is equal to k last year, and we made that kind of our normal equation that we used to fill it in based off of y equals kx. That was the equation. We're going to have a very, very similar equation this year. The only difference that I want to make is that instead of k, I now want it to be m. So we're going to have m, okay, so we're going to get rid of that, and now it's going to be m is equal to y over x. It's the same number, it's the same value, we find it the same way, everything's the same. We're just changing the letter that represents it, simply because when it comes time for slope-intercept form here in the short future, we're going to need m as our variable in this equation, so that way we have an actual slope. Okay. The rate is 5 pages in 9 minutes. As we said before, time is your x value almost all the time. And in fact, we know that it is our x value here. Here they call it your t value in dealing with p. So really, your m, your rate, is going to be pages divided by time. So what this looks like for this individual equation is P equals, and then our rate is 5 pages in 9 minutes, so it's 5/9 T. Okay? Again, the equation, we have our X and we have our Y, and in this case we have our T and our P. It just takes the place of what would be our X and our Y. Our left column is always going to be our X. Our far right column is always going to be our y. So, when we put in our equation, P equals 5/9 T, we're going to use this equation. So this is your answer for part A. Okay. We're going to use that equation for part B to then fill in the rest of these to figure out how many pages that Vicky can read over any time interval. Again, that's kind of the point, is to figure out over any given time interval, how many pages can she read at this constant rate, that rate being 5/9. So we're going to take our value for T, and we're just going to plug it into our equation. So the amount of pages that she can read at this rate in 0 minutes is 0 pages. Anything times 0 is going to be 0. Duh, P equals 0. Okay. Now, this is where your calculator is going to come in handy. So, they want you to round your answer to the nearest tenths place. It says so right there in the problem. So you need to make sure you have a calculator handy, because we're going to be multiplying a fraction of 9, which gives us a lot of repeating decimals that we're going to have to round. In this case, for the second one, P equals 5/9 times 20. So, you can do this, again, one of 2 ways. If you have a nice scientific calculator, you can plug it in as 5/9. times 20, put them all in parentheses, and follow order of operations that way. Or you can break it down a little bit more, and if you have just more of a simple calculator, but and still get the answer. So you can do one of two things. You can do 5 divided by 9, and then in parentheses, multiply it times 20. And that's going to give you 11.11111. Or you can do 5 times 20 divided by 9. And it's going to give you 11.11111. So, either way you want to do it, you're going to get the same value, 11. We'll call it 1 pages read. So, now with 40, 5 pages, 9 minutes, and then this is in 40 minutes. So, again, same thing. In this case, we're going to do 5 times 40, which is 200 divided by 9, to get 22.2. Again, rounding it to the nearest tenth place. And then finally, you can probably take a guess of what's going to happen here. 60 times 5 is 300 divided by 9 is 33. 60 is 33.3 pages. So, there's our table. And then finally, part C asks, how long would it take if she were to read 25 pages? So, we take the pages, and that plugs in for our P, obviously. So 25 equals, we have the same rate, 5/9. And in this case, we need to find the T value. We divide both sides by 5/9. So we have 25 over 1 times 9 divided by 5, because we have to keep, change, flip. 5. Let's figure out what 25 times, nope, not divided by, 25 times 9 is 225. 225 divided by 5 is 45. So, it would take her 45 minutes to read 25 pages. And so that is going to be our answer for C. So, to recap, we took our values here, we put them together as our expression, as our y over x. We call that our m. In this particular case, we have p and t. We need to be able to recognize that not every equation is always going to have a y or an x for a variable. Sometimes it'll have p, sometimes it'll have t. A lot of times it'll have t for time. So as we're doing that, we need to make sure that t is always in the same place as our x value. All right? And then whatever is over here on the far right column is going to be our y value. We put them together the same way. Y over x, p over t, whatever the variables that they want you to use, you need to make sure you have them set up correctly. And then you need to make sure that you have your numbers that are given to you in your problem also set up correctly to create your rate, to create your constant of proportionality, to create, in this case, your slope. Use your linear equation by plugging in your value for t. Your given values for t over here, you plug them into your equation, and then you get your values for p in your far right column. Then, of course, part C. And so your assignment for today, that's due tomorrow, essentially asks you to do part A and then part C. It has you skip part B. When you get into these lesson problem sets, 1, 2, and 3, really they just want you to do part A, and then they really want you to do part C of that exit ticket, which is to just answer a question using that equation that you put together in part A. So, that's it. If you have a question, send me an email. This will probably be the only video that I have made for you before Thanksgiving. So if I do not see you beforehand in a meet, have a great Thanksgiving. Enjoy your time off. Adios.